Okay, now we're going to look at D1. So D are projectiles launched horizontally. All the practice problems are the same. So it says a baseball rolls off a 0.7 meter high desk and strikes the floor 0.25 meters away. How fast was the ball rolling? So first of all, the first thing I have to do is I need to draw my picture. So this is where the ball started, and it rolls off horizontally. So the path of the projectile is going to look like this. This is my initial velocity. Now, the thing is, they tell me two things. They tell me how high this is, y, and then they tell me how far it rolls off the edge. What they don't tell me is my initial velocity. That's what I have to find. So this one is a little bit different than what we did before. But we're not going to do anything different. What I'm going to do is I'm going to write my given, and I'm going to have two columns. I'm going to have my x and my y given. The first thing I'm going to do is I'm going to say that ax is 0 and g is equal to negative 9.8 meters per second squared. Because in every single problem I do for any type of projectile, I'm always going to write that first for my given. I'm not going to forget that. The next thing I said to do is break my initial velocity up into my horizontal and vertical components. The problem is they didn't give me the initial velocity. But I do know when it rolls all like this, it's going to be initially all horizontal. So I know that Vix, I'm not sure what that is, but what I do know is that Viy is 0. So that's actually something important that I need to write in my given. The next thing I'm going to do is I'm going to say, well, what else did they give me in the problem? Well, they told me that x is equal to 0.25 meters, and they told me that y is equal to negative 0.7 meters. Okay, what do I do next? Well, how do I know what to do? When you don't know what to do, you go to the end and you say, what do I want to find? But you also need to look at your given, okay? Now, in my given, where I start is the side that I have three things. So I see here, I actually have three things here. So now I know I'm going to start here with this side with three things. So then I'm going to say to myself, what do I have? Well, I have little g, I have Viy, and I have y. So what can I find? Now remember, I told you there's one thing. I want to find Vix. And I know later on, I know that Vix is actually equal to Vi. And I know that if I want to end up finding, since I was given x, later on, if I use that equation, x is equal to Vxt plus 1/2 axt squared, and this is 0, I know that I'm given x. This is what I want to find, so what else do I need? So when you don't know what to do, you go to the end. I want to find Vix because that's equal to Vi, so I also need t. So if I have g, I have Viy, and I have y, can I find t? Yes. So what I'll do is I'll find t. Once I find t here, t is the same on both sides because t is scalar. Doesn't have, t is not x or y. T is the same. And then I can go back and I can use the t on this side. So y is equal to Viyt plus 1/2 gt squared. Because Viy is 0, this whole term goes to 0. So now I have y is equal to 1/2 gt squared. I'm going to rearrange the equation to solve for the unknown in terms of the known before I substitute and solve. So I'm going to multiply both sides by 2. I'm going to divide both sides by g, and then I'll take the square root of both sides, and that's equal to t. So now I'll substitute in my values. 2 times negative 0.7 meters divided by negative 9.8 meters per second squared. Now the negative in the numerator cancels with the negative in the denominator. And my unit, if I have a meter, remember when I carry my units through and cancel them, it checks my work. So a meter divided by a meter per second squared under a radical is the same as a meter times a second squared over a meter. These cancel, so the square root of a second squared is a second. Is that the correct unit for time? Yes. And then when I do it on my calculator, I have 0.7 times 2 equals divided by 9.8 equals, and then I take the square root of the whole thing, and it comes out to be 0.379, which we'll say is 0.38. So t is equal to 0.38. So once I have t here is 0.38, then t here is 0.38. Do I have three things now on the x side? Yes. So now I'm going to say x is equal to VIXT x. So x divided by t is equal to VIX. So it's 0.25 meters divided by 0.38 seconds to be 0.658. So we'll say 0.66 meters per second. So that's VIX, but because this is all horizontal, VIX is equal to VI, so VI is 0.66 meters per second. So again, any problem in physics can be worked systematically, step by step. So the first thing you're going to do for any projectile motion picture is you're going to draw your picture. Okay? Once you draw your picture, you're going to look at, is it all horizontal? Because in the next time, or next lesson, we're going to do it where it's launched at an angle. Okay? So after you draw your picture, you're going to write your x and your y given. Remember, AX is always 0, G is always negative 9.8. You're going to look at your horizontal and vertical components of your initial velocity, and then you're going to see what else you're given in the problem. And then you're going to say, which side do I have three things on? So once you see which side you have three things on, that tells you you're going to have to do something with that side. That's where you're going to start having to calculate something. And if you're not sure what direction you're going in, you go to the end and you say, well, what am I looking for? Because if I went to the end and I said, well, I wanted to find VIX, and I already have X, what else do I need to do to find that? I need the time. And then you're like, oh, okay, now since I have things on the Y side and the time is the same on both, what I'll do is I'll find the time in order to do that. Okay? So you can do all these problems step by step, and that's it.